Why did we choose to represent the numbers in this way and not some other way? Well, let's consider the real numbering system that we're used to. When you count up to 7, 8, 9, and then 10, you'll notice that after 9, you have to now have two different digits, a 1 and a 0. A 10 is actually 1, 0. Once you get to 10, you have to add another column of symbols because we don't have a one single symbol for 10. We only have symbols for 0 through 9. 07, 08, 09 is followed by 10 because in our normal numbering system we have 10 different symbols, 0 through 9. So when we get to the 10th number, we have to carry the 1 back to the next column. This is the same when it comes to light switches or electricity. We can't have a switch being on and off and somewhere in the middle. It can only either be on or off. We represent off as a 0 and on as a 1. So let's look how we count using the same methodology with binary numbers, or numbers made out of two states, ones and zeros. First, all three zeros are represented as a 0. This makes sense. This is very similar to what we have in our normal numbering system. When we add 1 to that, we add 1 to the first column. 001 is still a 1. Now to go to number 2, we don't have any other symbols because remember our wires can only be either off or on. There's no other state that they can be. So we have to move to the next column like we do from 09 to 10 in the normal numbers. When we run out of symbols, because we only have two of them, a 0 and a 1, we have to roll to the next column. So 2 is now 10. Because you've added 1 to it, you had to move up to the next column. When you add 1 to this again to make 3, it's 011. Just like when we went from 1 to 2, when we go from 3 to 4, we have to roll up to the next column because we don't have any more symbols other than 0 and 1. That's why 4 is 100. You add 1 to that is 5. Let's consider numbers that we're used to again. When you're counting up from 1097 to 1098 to 1099, you've run out of symbols in the first and second column, so you increase for 1100, you increase the third column to a 1 and roll the two 9s back to zeros. Same thing happens in binary when we go from 5 to 6. We're out of symbols in the first column, so we move the middle column to a 1 and the first column back to a 0. Adding 1 to that again to get 7 is 3 1s. Likewise, when we now have all 1s, to count up again, we roll them all to 0 and the next column becomes a 1. This continues on and on, just like real numbers keep adding columns and counting up and rolling over and counting up and adding more columns. With 4 wires or 4 decimal digits, you can represent 16 different numbers, 0 through 15.